Okay, I'm just going to go through the day 2 proofs. So you guys always have this as a video to look back on when you're studying. Okay, so starting with the first one that we did, M is the midpoint of AB and M is the midpoint of DC. Okay, so I'm going to mark up my picture here. If M is the midpoint of AB, then I know that AM must be congruent to MB, and I also know that DM must be congruent to MC. I want to prove that AMC, this triangle, is congruent to BMD. Okay, so we know a bunch of different ways that we can prove triangles are congruent. And thus far we've talked about side, 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 angle, side, angle, side, angle. When I'm looking at this picture, I see I have two sides, and I'm looking at these angles and thinking, I know these are congruent because those are vertical angles. So I'll just call them 1 and 2. If I have vertical angles congruent and these corresponding sides, this follows as side, angle, side, where the included angle is congruent. It's included in between the two congruent sides. And then I will have had it proved. So now I just got to write up my proof. So first we always write out our givens. Okay, let's talk about those sides being congruent first, because they didn't tell us that, each of these sides were congruent. They just said that M was the midpoint. So I got to explain why I know that they're congruent. So I'm going to say AM is congruent to MB. And I'm also going to say that MD is congruent to MC. And that's because a midpoint divides a segment into two congruent segments. Okay, so now I got my sides of my proof. I gotta talk about the angles now. Angle 1 is congruent to angle 2, and that's because vertical angles are congruent. Alright, I've talked about my two sides, I've talked about my angle, I've got side, angle, side, so I'm going to mention that now at my last step. So triangle AMC is congruent to triangle BMD. And that's by side, angle, side, congruent to side, angle, side. Okay, next, I've got KJ congruent to JL, and it tells me that JM, which is this segment right here, bisects KJL, so that's here. Okay, so if I know that that's an angle bisector, then these angles, which I'll call 1 and 2, must be congruent. Okay, so I got to remember to talk about that. I'm trying to prove that these two triangles side by side here are congruent. Something that I'm seeing is they have a shared side, JM. So I'll have to talk about that with reflexive property. So based on my picture here, I have side, angle, side. So I have the triangles then congruent by side, angle, side. So this is my plan. I just got to write it up now. Let's talk about the reflexive part first. So I'm going to say JM is congruent to JM, and that's the reflexive property. I got to talk about those angles being congruent, right? I have them marked in my picture, but I have nothing about it in my proof because they didn't tell me the angles are congruent. I had to infer it from that step right there. So I'm going to say angle 1 is congruent to angle 2, and that's because an angle bisector divides an angle into two congruent angles. Alright, so they gave me the side, I talked about another side, and I have the angle in my proof, so that's good. So I talked about everything I needed to. So now I can say that triangle JKM is congruent to triangle JLM. That's because side angle side. JR bisects KL, so JR is bisecting now a segment. Okay, so we got to be careful here. I'll put a little star next to this. If JR is bisecting KL, I have to talk about how R is the midpoint. Now, if R is the midpoint, then I know it's dividing the segment into two congruent segments. I also know that JK is congruent to JL, so I'll mark that. I'm trying to prove that these two triangles side by side here are congruent. Well, I see a shared side. So I have these triangles congruent by side, side, side. But, as usual, I got to write it up. Okay, so let's talk about R first. Remember we said that JR bisects KL? We're going to say that R is the midpoint of KL. And that's because, okay, remember this from Unit 1. A segment bisector intersects a segment at its midpoint. Okay, now we can say that KR must be congruent to RL because a midpoint divides a segment into two congruent segments. Okay, and I'm going to put a little highlighter here. Okay, this is something that you have to write. It's a two-step proof there, all right? So don't just jump to KR is congruent to RL. You have to talk about the segment bisector first, then and that it's a midpoint, and then talk about the midpoint. Okay, so next, what do I want to talk about here? All right, so I got to talk about JR still, right? Because I know it's congruent to itself. It's going to bug me that I used a different color. Okay, so let's see so far. I've talked about this side. I've talked about this side, or sets of sides I should say, and they gave me this side, so I have everything I need. That's side, side, side. So now I can say that triangle JKR is congruent to triangle JLR, and that's by side, side, side. Okay, next, CF bisects, so here's CF, bisects DCE. Okay, so that means that, I hate these lines, I'm going to erase them. That means that these angles must be congruent, which I'll talk about that. CF is perpendicular to DE, so that means these angles in here must be right angles. So I'll label them 3 and 4 and label them as perpendicular. Okay, if I'm trying to prove these two triangles are congruent, I'm noticing the shared side. So this is by angle, side, angle, and all right angles are congruent, so I know 3 and 4 are going to be congruent to each other. Okay, so let's talk about the angle bisector first. I know angle 1 is congruent to angle 2. And that's because an angle bisector divides an angle into two congruent angles. Next, I'll talk about CF being congruent to itself. Right, that's the shared side in here. And that's the reflexive property. Okay, so 3 and 4 are going to take a little bit of work here. First thing I'm going to say is that angle 3 and angle 4 are right angles. And that's because all they told me was that those two segments are perpendicular, so all I can conclude is they're right angles. So perpendicular lines create right angles. Now what do I know about right angles? Well, they're all going to be congruent to each other. So I'm going to say that angle 3 is then congruent to angle 4, and that's because all right angles are congruent. Had to shift this down a little bit. Okay, so then, let's see here. I have the angle talked about. I have the side. I have the angle. There's angle, side, angle in my proof, so I'm good. So I can now say that triangle DCF is congruent to triangle ECF, and that's by angle, side, angle. Okay, one other thing I should mention here is that steps 4 and 5, that's another two-stepper where you're not just going to jump and say 3 and 4 are congruent. You have to say first that they're right angles, then that they're congruent, because all right angles are congruent. Okay, next, PQ is congruent to RS. PQ is perpendicular to QS, and RS is perpendicular to QS. And I want to prove that these two triangles are congruent. So let me outline them in different colors. Okay, so just by me doing that outlining, you can see where it turns into this like black color. That's where they're overlapping. So that's a shared side. Something else that may be helpful is if you pull them apart. Use the different colors to help you. Like here's the green triangle, here's the pink triangle. Now I mentioned there was a shared side, right? So technically that's congruent to itself. That didn't really show up there. So I'll mark them on here. Here's that shared side I'll talk about. They gave me that these two sides are congruent. I know that these are going to be right angles, so they will be congruent. So I'm kind of like using both diagrams here. So it looks like if I'm trying to prove that they're congruent, I'm going to use side, angle, side. Okay, so pulling apart overlapping angles will help you. Okay, so let's start with our givens. Okay, let's actually talk about that shared side right away. That was QS. And that's by reflexive property. Okay, I'm going to talk about these angles. Now, according to the original diagram, see how I have like lines going all over the place? You don't want to say angle Q because that's not being specific enough. Let's say PQS. So angle PQS and angle RSQ are right angles. And that's because perpendicular lines create right angles, and then I'm going to say they're congruent. It's because all right angles are congruent. Alright, so I was given a side here, right? I talked about another side. I talked about my angles. So I now have that the triangles are congruent by side, angle, side. All right, last example here. I've got JK parallel to ML, and I've got JM parallel to KL. So I've marked them in my pictures with those arrows. And I want to prove that JKM, this triangle, is congruent to LMK. Alright, well, given that they gave me parallel lines, think of KM as a transversal. So if I focus on JK and ML, I see right away that I've got these two angles here, which I'll label 1 and 2. Those are alternate interior angles, so they would be congruent. On JM and KL being parallel, focus on that transversal again, I'm going to see that this angle I'll call 3 will be congruent to this angle I'll call 4, because those are also alternate interior angles. So I have two angles congruent within these two triangles. I also have a shared side that is MK. So I have these two triangles congruent by angle, side, angle. Alright, so let's talk about this. Givens. Okay, I'm going to first talk about angles 1 and angle 2. Angle 2. Angle 1 and angle 2 are congruent, and I'm going to say if two parallel lines are cut by a transversal, alternate interior angles are congruent. Now, by the same reasoning, I knew 3 and 4 were congruent. By the same exact justification that I had two parallel lines cut by a transversal and alternate interiors are congruent. So under the same step, I can also say 3 and 4 are congruent. Okay, don't forget about that shared side, right? That's MK is congruent to MK, and that's by reflexive property. Okay, so I have angle, angle, okay, side. So angle, side, angle. I've talked about them all in my proof. So I'm good. Now I can say that they are congruent. So JKM is congruent to triangle LMK, and that's by angle, side, angle. And we're done.